Okay, so going back to those three previous cases, let's see if we can just practice finding differential operators that annihilate each of the following given functions. So in 1 plus 5x squared plus 8x cubed, that's just a collection of polynomial terms, in which case I'm looking at the highest exponent, and that's what's going to define what we use to cancel out. So since I'm looking at a third degree polynomial, if I take the differential operator of fourth degree, that should cancel out that polynomial expression. So the fourth derivative of that polynomial would equal 0 then. What about e to the negative 3x? Okay, so that would be that second case that we looked at. So I need a d minus, and then I need the alpha, which in this case would be negative 3, e to the negative 3x. So I'll kind of simplify that real quick. So d plus 3, e to the negative 3x. Oops, sorry, drop that there. And just kind of walk through what this is, why this works the way it works. So if I take the derivative of that expression plus 3e to the negative 3x, okay, so what's the derivative of e to the negative 3x? That's negative 3e to the negative 3x plus 3e to the negative 3x. Okay, what do we notice? Those two guys cancel out. So that's why that magic works. Okay, and so in this last case, 4e to the 2x minus 10x e to the 2x, I'm looking at essentially a more complicated term. So the x e to the 2x and e to the 2x actually fits in that second pattern again. So I need to identify my alpha and my n. So alpha would be the exponent of the x, and n would represent the highest degree, and that would be 2 in this case. So my differential operator would be d minus 2 squared times 4 e to the 2x minus 10x e to the 2x on that. And again, let's kind of have a little fun with this, and let's just see, well, why does this in fact cancel each other out? So let's do a little bit of multiplying and see for ourselves. Okay, so that d minus 2 would be d squared minus 4d plus 4. That's 4 e to the 2x minus 10 x e to the 2x. Okay, and so I'm going to just do this term by term. So I want d squared 4e to the 2x minus 10x e to the 2x minus 4d 4e to the 2x minus 10x e to the 2x, and then plus 4 4e to the 2x minus 10x e to the 2x. All right, so I got to take the second derivative. I'm going to screw this up a little bit. Okay, that was a little bit of scooting there. Okay, so I can see that I'm going to have to do a couple derivatives here. So I'm going to take advantage of this empty space up top here, so just bear with. And I want to do d of 4e to the 2x, which is 8e to the 2x, and then d squared of that same expression. So let's just do another derivative. Let's do that. So take a second derivative of 8e to the 2x. That would be 16e to the 2x, which means the second derivative of 4e to the 2x is 16e to the 2x. Okay, so I'm going to need essentially both components in a moment. So I need this guy and this guy. The more complicated one is the derivative of negative 10x e to the 2x. So that is a product rule. So it's negative 10 first times the derivative of the second, which is 2 e to the 2x plus e to the 2x times the derivative of the first. Oops, that got put off my screen there. Sorry about that. So that would be negative 10x, negative 20x. Sorry, I'm trying to simplify this down here. 10x e to the 2x. It's negative 20x e to the 2x plus e to the 2x. All right, and then I want to take derivative of that. So negative 20x e to the 2x plus e to the 2x. All right, so that's negative 20 x times 2 e to the 2x plus e to the 2x times 1 plus, oh, I'm off the screen again. I'll have to clean this up at the end here. All right, what have I done? I've done product rule at this point, so I need just the derivative of e to the 2x. So that's just 2 e to the 2x. Okay, so I'll just state this as the second derivative of negative 10x e to the 2x is negative 20x, negative 40x, sorry. Ooh, did I distribute that 10 in? I did not. Oh boy, oh bother. All right, yeah, I just caught that I didn't distribute that negative 10 through. So it should be minus 10 e to the 2x. All right, so that's going to change this. Dun, 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 dun. Okay. So that part I can get rid of. Okay, so that piece is all times negative 20. And then minus 20 e to the 2x. Okay. All right, so now let's try to clean this up. So that's minus 40x e to the 2x minus 20 e to the 2x minus 20 e to the 2x. And of all of this, I need this piece for the second derivative, and I need this piece for the first derivative. Okay, so let's scroll back over and see if I can get that relevant stuff. All right, so I'm gonna collect this up here. So for second derivative of 4 e to the 2x, so that's 16 e to the 2x. And then the second derivative of the minus 10 x e to the 2x is minus 40x e to the 2x minus, and I think those are, we can just like term that, so minus 40 e to the 2x. All right, minus 4 times the first derivative of 8 e to the 2x, and then the other term, which was minus 20 x e to the 2x minus 10 e to the 2x. And then plus the 4 e to the 2x minus 10 x e to the 2x. All right, so if we did this right, stuff should cancel out. So I'm looking at the 16e to the 2x. I got a, what is that, 32. I got another 16, so those guys all cancel out. And let's look for my x e to the 2x's. So x e to the 2x right there. And that's another minus 40. So I'm sorry, that's plus 80, minus 40, minus 40 back in here. So that cancels out, that cancels out, and that cancels out. And I realize I could have done like terms again. There's a minus 40, and there is a plus 40. So that's all going to cancel out. Okay, so point is, it works. Hooray.